Okay, this is 9.1 chemistry. I think my mic is good. Uh, whoa, where's the question? Whoa. Okay, we're back. We fixed it. They gave us two graphs here. Okay, this whole chapter is about it's reaction rates. Okay. Uh, Here they gave you two graphs. Okay. In general, okay. Whoa, shit. The reaction rates. Okay. A reaction rate would be like, let's say you have Na plus Cl to produce NaCl. Okay. Uh, a way you could measure how fast the reaction is, you can measure two things. Okay, you can either measure the concentration, because this could come the concentration. Sorry, no, sorry. You can measure the decrease of reactants. Okay, concentration of the decrease of the reactants, or the increase in products. Okay, in the products. What do I mean? So look, when this Na plus Cl reaction is happening, as it happens, let's say you start with 7 grams of Na, 15 grams of Cl. Okay, obviously you're going to end up with 23 grams of NaCl. But what I'm trying to say is you can measure the decrease of reactants. So let's say every minute, okay, I'm losing 1 gram of Na and 1 gram of Cl. So that means the reaction would be 1 gram per minute. Okay, being used up. How about increase? Okay, I could also measure how much NaCl I'm getting in each minute. So let's say each minute I'm gaining 1 NaCl, so again, that would be 1 gram per minute. Okay, this is just an example. So you can either measure the decrease of the reactants or the increase in the products. So we have two graphs, okay? One of them shows the reactants, one of them shows the products. And this is a concentration. Obviously, the one decreasing will be the reactants, right? So graph A will be the reactant, and the one increasing will be the product. Okay, that's how it goes. Question 2, okay, it should be a graph. Okay, there are four ways, I think, yeah, four ways, okay, to increase the rate of reaction. The first one is temperature. Okay, the second one is surface area. Okay, the third one is the concentration of reactants. Okay, concentration of reactants. And the fourth one, I'm not sure if they ask it, but it's pressure. Okay, pressure. When you increase temperature, that means there's an increased rate of reaction. When you increase surface area, that means there's an increased rate of reaction. When you increase the concentration, then there's an increased rate of reaction. When you increase pressure, then there's an increased rate of reaction. Okay, this all comes from the collision theory. Okay, the collision theory basically states three things. Okay, particles have to yeah, here is the collision theory. For a reaction to proceed, the particles must collide with each other. Okay, so if a reaction has to happen, this Na has to touch this Cl. Okay, they have to collide with each other. And they have to collide with a minimum amount of energy. Okay, this amount of energy, this amount of energy, okay, it basically says يعني when they react they can't just collide, مش بس they collide, they have to collide with some sort of energy pushing them, and that is what you call the activation energy. Okay, if they actually collide we call it a successful collision or an effective collision. Okay, and to increase the rate of a chemical reaction, okay, to increase the rate of a reaction, that means you're increasing shit, what the fuck, that means you're increasing the frequency of effective collisions. Okay, yani if the rate of reaction is increasing, basically what's happening is the particles are colliding more, and to get them to collide more you increase the temperature, increase the surface area, increase the concentration, or increase the pressure. Okay, questions like this will come in the written. Okay, I think this question here will come in the written. What will explain the effect of changing the concentration of on the rate of reaction? You have to say this. Obviously, I'm going to summarize it for you. You say increasing concentration of reactant increases number of particles. Okay. Then you say there will be more collisions. They will collide more frequently, so number of collisions will increase, and then rate of reaction increases. These 3 points you have to write. Okay, to get the mark. And they'll probably give it as a 3-mark question. Okay, these are the notes. I suggest you go over them. They're very useful. You can, all of this here. Health and I don't think this is coming. Reaction mechanisms, they're not coming. Okay, so I think it's until here, until example 3. You can do it. Okay, let's go back to the quiz. The rate of the reaction from A to B increased. Obviously, A is done here. They have the same end product, but B was faster, right? You see, B increased quicker. Okay, it was more steep or steeper. Which of the following changes, perturbations means changes, could have yani, happened? Okay, they're saying this is a reaction of magnesium with excess hydrochloric acid, and they say hydrogen gas is produced. Okay, look, whenever you see excess, okay, that means if you increase its concentration, there will be no change. Okay, if you increase the concentration, there will be no change in the reaction. Okay, you will still get the same amount of products, but it will be faster. Okay, it will be faster, but the amount of product won't change. Okay, because it's excess. But مثلا if I increase the number of magnesium, then I'll get more product. Okay, but this is يعني this has nothing to do with what we're doing. We're talking about the rate, and that means the speed. So if you increase this, it will be faster. المهم, what could have changed? Okay, could we have used magnesium powder? Yes. Magnesium powder meaning we increased the surface area, because it was magnesium blocks. If you cut them up into smaller pieces, there would be a larger surface area. I know it might sound confusing. It's smaller. How is there larger surface area? It That's how it goes. Okay, surface area. The more pieces you have, the more numbers of pieces you have, then there's more surface area. Using less amount of magnesium ribbon, obviously not. If we use less, then it's gonna be slower. Warming the acid solution, yes, that means they're increasing the temperature. Adding a catalyst, I forgot to mention the catalyst. Okay, also you could add a catalyst. Okay, basically what a catalyst is, it's it's a substance. For those who do bio, a catalyst would be an enzyme. Okay, basically it increases the rate of the reaction. Okay, it's just a substance you could add to the reaction that just speeds it up. Okay, it just speeds it up. It's like a boost. Okay, so a catalyst also works. Decreasing surface area, obviously that's wrong. Okay, question 3. Okay, you have four graphs, A, B, C, D, five graphs, A, B, C, D, E. Okay, C is the original graph. Okay, it's the original one. They're saying, okay, what would happen if a leakage of gas occurred? Which graph would it be? So obviously, if it leaked the gas, okay, well, let's read it first. When zinc reacts with hydrochloric acid, okay, hydrogen gas was produced. Okay, so what would happen if the gas leaked? Okay, so what's gonna happen? This is the reaction of the products. They said the hydrogen produced. So if C was my original one, what would happen if it leaked? Obviously, we're gonna have barely any more product left, right? So it's gonna be E. It's gonna be the lowest one, since they all leaked out. All of the hydrogen leaked out. Part B, only half the zinc is used. Okay, if half the zinc is used, so from part C, half the zinc is used, we're at 30. What's half of 30? 15. And graph D is at 15. Okay, question part C, a slightly warmer excess acid is used. Okay, if you realize they're saying warmer, okay, warmer doesn't change how much product is formed. It only changes the rate. It doesn't mean I'm getting more. Still, if I had 7 grams on the left, I'm gonna have 7 grams on the right. Just because the temperature change doesn't mean I'm gonna get more products. No. Okay. So what's gonna happen? It's only gonna change the rate. So let's take a look here. C was my original one, and if it's warmer, it's gonna have the same end product. You see how they're at the same line at the end, but B was quicker to reach that product. You see, it reached quicker. It reached higher amounts faster. Okay. Part D, a greater mass of zinc is used. It's gonna be graph A. Okay, since we're using more zinc, it's gonna be graph A. Okay, that means I had more products. Since I'm adding the mass on the left, that means I'm gonna add more hydrogen product. Okay, more zinc means more reactants, means more products. Okay, if they said they added more hydrochloric acid, it wouldn't be A. No, it would be B. Okay, because I told you when they add excess, the amount of product doesn't change. Okay, please be careful. They might ask you that because I think they asked it in the notes over here. Yeah, the excess acid. Okay, I think, yeah, now part B. What's the final volume obtained in experiment C? You just go to graph C over here. What's the final volume? I should draw this in red, actually. What's the final volume? Just trace it 30. That's it. يعني. Okay, هلا 9.2. 9.2. Yes, it is. One question. Chemical kinetics is the study of the reaction rates. Thank you. No, 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 no. Wait, I'm not done. I have to get this video above 10 minutes. So I think, yani, you should go over the book, yani, because they say a lot of stuff here. They could ask you, how would you calculate the rate of NO2? You just say how much NO2 produced per time. Okay, they would say seconds or whatever. No, you could just ask it like that. Okay. What else do they say? Like, let's see over here. Like, what could they say? I think this is also part of 9.2. Um, increasing the concentrate. This is like a summary, you know. Like I said, bro, go over the notes. They're very important. Wallah. I think that's now 10 minutes. Yup. Okay. Thank you so much for watching. Good luck.